Hello and welcome to the office hours. My name is Will, and today we're going to be learning about BGP on NetworkLessons.com. So here it goes. So Border Gateway Protocol is a routing protocol of the internet used to route traffic from one autonomous system to another. It's an important topic to understand if you work for an ISP or a large company that is connected to two or more ISPs. Unlike integrated or internal gateway protocols like OSPF and EIGRP, BGP uses a set of attributes to determine the best path for each destination. There are lots of options you can use to manipulate traffic patterns. The course highlights are what BGP is, the differences between internal and external BGP, how to read the BGP table, how BGP uses different attributes instead of metrics to make routing decisions, what BGP communities are, how to filter BGP networks, advanced topics like BGP peer groups, route reflectors, and confederations, among many others. This is presented by Reen Molinar. I suppose he's a CCIE, and there's his number. So the requirements are CCNA routing and switching, which I have, but it's expired, so hopefully that's good enough. And have a good understanding of IGPs, such as RIP, OSPF, and EIGRP. All right, let's look at the introduction. Introduction to BGP. This lesson will be interesting. Border Gateway Protocol is a routing protocol that glues the internet together. I'm going to explain in which situations we need BGP and how it works. Before you continue reading, I should tell you to forget everything you know about routing protocols like RIP, OSPF, and EIGRP so far. Those three routing protocols have one thing in common. They are all IGP, Interior Gateway Protocols. We only use them within our autonomous systems, but they are not scalable to use for a network as large as the internet. RIP, OSPF, and EIGRP are different, but they all have one thing in common. They want to find the shortest path to the destination. When we look at the internet, we don't care as much as to find the shortest path. Being able to manipulate traffic patterns is far more important. There is only one routing protocol we currently use on the internet, which is BGP. Oops. Why do we need BGP? Let's start by some scenarios so that you can understand why and when we need BGP. Nowadays, almost everything is connected to the internet. The picture above, we have a customer network connected to an ISP. Our ISP is making sure we have internet access. Our ISP has given us a single public IP address we can use to access the internet. To make sure everyone on our LAN at the customer side can access the internet, we are using network address translation or port address translation to translate our internal private IP addresses to the single public IP address. This scenario is excellent when you only have clients that need internet access. On our customer LAN, we only need a default route pointing to the ISP router, and we are done. For this scenario, we don't need BGP. All right, so another scenario, maybe the customer has a couple of servers that need to be reachable from the internet, perhaps a mail or web server. We could use port forwarding and forward the correct ports to these servers so we still only need a single IP address. Another option would be to get more public IP addresses from the ISP and use these to configure the different servers. For this scenario, we don't need BGP. What if we want more redundancy? Having a single point of failure isn't a good idea. We could add another router at the customer side and connect it to the ISP. You can take the primary link for all traffic and have another link as the backup. We don't require BGP in this situation. It can be solved with default routing. Advertise a default route in your IGP on the primary customer router with a low metric. Advertise a default route in your IGP with a secondary customer router with a high metric. This will make sure your IGP sends all the traffic using the primary link. Once the link fails your IGP, once the link fails, your IPG or IGP will make sure all traffic is sent to the backup link. Let me ask you something to think about. Can we do any load balancing across these two links? It would be difficult. Your IGP will send all traffic down the primary link and nothing down the backup unless there is a failure. You could advertise a default route with the same metric, but you'd still have something like 50-50 load share. What if I wanted to send 80% of the outgoing traffic on the primary link and 20% down the backup link? That's not going to happen here, but with BGP, it's possible. This scenario is a bit more interesting. Instead of being connected to a single ISP, we now have two different ISPs. For redundancy reasons, it's important to have two different ISPs. In case one fails, you will always have a backup ISP to use. What about our customer network? We still have two servers that need to be reachable from the internet. In my previous example, we got the public IP address from our ISP. Now I'm connected to two different ISPs, so what public IP addresses should they use from ISP1 or ISP2? If we use public IP addresses from ISP1 or ISP2, then these servers will be unreachable once the ISP has connectivity issues. Instead of using public IP addresses from the ISP, we will get our own public IP addresses. The IP address space is maintained by the IANA. IANA is assigning IP addresses or IP address space to a number of large regional internet registries, such as RIPE and ARIN. Each of these assign IP addresses to ISPs or large organizations. When we receive our public IP address space, then we will advertise this to our ISPs. Advertising is done with a routing protocol, and that would be BGP. If you're interested, here's an overview of the IPv4 space that has been allocated by the IANA. Actually, let's take a look at this. Cool. An autonomous system is a collection of networks under a single administrative domain. The internet is nothing more than a bunch of autonomous systems that are connected to each other. Within an autonomous system, we use an IGP like OSPF or EIGRP. For routing between different autonomous systems, we use an external gateway protocol. The only EGP we use nowadays is BGP. How do we get an autonomous system number? Just like the public IP address, you'll need a register one. Autonomous system numbers are 16 bits. Just like private and public IP addresses, we have a range of public and private AS numbers. Range 1 to 64511 are globally unique AS numbers, and this other range is a private. If you're interested, see if you can find the AS number of your ISP. Now let's take a look. How about I just enter Comcast? Oops. Comcast has a whole bunch, right? Cool. All right. BGP has two flavors. External BGP, used between autonomous systems. Internal BGP, used within autonomous systems. External BGP is to exchange routing information between different ASs. In this lesson, I explain why we need internal BGP. I would recommend to read it first, or to read it after finishing this lesson and learning about external BGP first. So let me open up these tabs. All right. BGP advertisements. You have an idea of why we require BGP and what autonomous systems are. The internet is a big place. As I am writing to you, there are 500,000 prefixes in a complete internet routing table. If you are curious, you can find the size of an internet routing table here. I would say currently there is 734K, and if you aggregate that down, you get about this much. Alright, cool. Back to where I was. Scroll down all the way to Category 2 IPv4 and IPv6 BGP route servers by region. There's a lot of material here. Okay. Ooh, there's some you could telnet to. Telnet. Nope. Maybe this is outdated. When we run BGP, does that mean we have to learn more than 500K prefixes? It depends. Let's take a look at some examples. So we have autonomous system 1, 2, and 3. This one has an address of 10.0.0.0/8, 20/8, and 30/8. And ISPs 1 and 2 connect to the internet, while the customers connect to ISP 1 and 2. Cool. Above in the picture, our customer network has an autonomous system number of 1 and some IP address of 10.0.0.0/8. Let's pretend these are public IP addresses. We are connected to 2 different ISPs, and you can see their AS numbers, AS2 and AS3, and IP addresses, address space 20/8 and 30/8. You can reach the rest of the internet through both ISPs. We can use BGP to advertise our address space to the ISPs, but what are the ISPs going to advertise to the customers through BGP? There are a number of options. They could only advertise the default route. They could advertise the default route and a partial routing table, and they can advertise the full internet routing table. So let's look at the 3 options. Alright, so it looks like ISP1 and ISP2 are sharing the default route to the customer. Receiving a default route requires the fewest resources on your router since you only have a single entry to reach any external network. The customer router will advertise its 10.0.0.0/8 network to both ISPs, which will advertise it to any other AS they connect to, and we use a default route to reach anything on the internet. The downside of this configuration is that our customer network doesn't know what's behind ISP 1 and 2. We have connectivity because of their default routes, but this can lead to suboptimal routing. If we only have the default routes, then we will send all the traffic to one of the ISPs. Here's what's going to happen if you only use default routes. Alright, so customer sends all their data to AS2, ISP1, which sends it to AS3, which probably goes to the internet. Our customer network only receives a default route from both ISPs, and we have chosen to use our default route of ISP1 to send all our outgoing traffic to. This means that whenever we send traffic meant for 30/8, it's going to be sent to ISP1, then ISP2. It's not a problem, but it's not optimal. So second option is to send a partial routing table of the internet to the customer from both ISPs. In addition to the default route, this partial update might include all IP addresses that the ISPs have assigned to their customers. Just like in real life, the more you know, the better off you are. Unless you believe ignorance is bliss. In the world of routing, having more routing information means you can make better routing decisions, but have less suboptimal routing problems than when we only have the default route. The last option we have is to receive the full internet routing table from both ISPs. This requires more resources, but we'll be able to make the best routing decisions. Take a breather break. I need water. Come out. There you go. All right. Path vector. BGP is called a path vector routing protocol. What does this mean? Take a look at this image. We have 4 autonomous systems, and we are running BGP to exchange routing information. In AS1, we have the network 1.1.1.0/24, and this advertises to AS2, AS3, and AS4. If we look at the BGP table for the router in AS4, then we will see the network 1.1.1.0/24, but it also stores the path we have to get through in order to get there. Store the prefix, but also the path it has to cross in order to get to 1.1.1.0/24. The output above is from one of the BGP looking glass servers. By using show IP BGP command, I can look up the BGP table, and we will see this router knows about the 1/24 network. The next hop IP address is 202.160.242.71. At the end of the line, you will see paths with numbers 7473 and 15169. These are the autonomous systems we have to get through in order to get to this network. Alright, BGP route selection. What all IGPs have in common is that all of them want to find the shortest path to the destination. BGP works differently. Since autonomous systems belong to different ISPs or organizations, we want to be able to selectively influence our routing. Take a look at this example. BGP allows us to use routing policies at the autonomous level, or autonomous system level. In the picture, I have all 9 autonomous systems and in Like what in the picture above, I have 9 autonomous systems, and in AS9 we have this network 192.168.9.0/24. If we look at AS1, then we have a lot of different paths we could take to reach network 192.168.9.0/24 in AS9. Does that mean the network administrator at AS1 can choose the path we are going to use? Not really, because of the following reasons. You can choose the exit path. AS1 can send traffic to AS2 or 4, so 2 or 4, but you don't make the routing decisions for other autonomous systems. Each autonomous system will only advertise the best path to your autonomous system. AS1 will only learn about the best path from AS2 and AS4 unless their best path fails. Only then we learn about the second best path. BGP uses a set of BGP attributes to select the path. These are covered in other lessons. In conclusion, hopefully this lesson has been helpful to understand the basics of BGP and why you would use it. In other lessons, we will take a closer look at the configurations of external and internal BGP, and also how the BGP path selection works. Any questions, leave a comment. Cool, I think I'm gonna end the stream and start another one or another session with the next lesson, so that it's in mini bits or mini bytes.